Hi all, I've written a version of the classic Minesweeper game for the Commodore 64 and ported it over to the VIC-20. If, like me, you spent way too much time when you're supposed to be working playing Minesweeper on the earlier versions of Windows, then this might be a bit of a nostalgic trip. Check it out. Okay, let's start with a quick overview of the game. So we've got a maximum of 10 rows. Let's go 10, keep it simple, we'll go for 10 columns as well. Let's say 10 mines, and there's our grid. And the keys, to play the game are the return key. Will actually investigate, see if there's a mine there. It reveals that location, and that's telling us we've got one mine around it. And the gamer keys W, A, S, and D for navigating around the grid. And if you want to flag one, you simply hit the space key. Now this is the basic version, and this is quite slow. I've compiled it, and that's improved the performance significantly. So what it's doing now, it's doing a flood fill where it's going through and looking for all the areas that don't have mines, and sooner or later it will come up and expose that. And as you can see, we didn't have that many mines, so it's exposed most of the grid already, and that gives you a big head start. And what you do is use space. We'll flag those. They're all obviously mines. Oh, actually up here we're not. That would be a mine. That would be a mine. That wouldn't be. So here I'm going to press enter. Anyway, you get the, if you've played Minesweeper anyway, you get the general idea. Let's have a look at the code. And here we are in CBM PRG Studio. The first two lines look a bit weird. They're rem statements with a bunch of odd characters. These are basically for the compiler to optimize the performance, and specifically setting variables to different types, such as integer variables and what Boss Basic calls a byte variable. Okay, so now for some real code. Let's start with dimensioning out some arrays. We're setting up the M being the mine field, and let's make that mine, and what you actually see on the display. And here we're setting up a queue for the flood fill. I'll go into that a bit more later. This is where this program, from a programmer's point of view, gets a bit interesting. I'll expand on that later. And here I'm just setting up an array with some color values for poking to the color memory map. Let's start with our initial grid references of X and Y. At 1, we're setting up our display memory and color memory. For various reasons, I'm subtracting out the display memory from color memory. That'll be clear later, just saving a bit of space on the line. Okay, let's set the screen and border colors to a light gray. I think I set that for. Now just a bunch of print statements that display the intro screen. And here we're inputting the number of columns we want, the number of rows we want, and the number of mines. And with some checks in place to make sure they're valid values. Okay, now we actually create the mine field. So we're looping through to the number of mines selected, selecting a random X and Y coordinate, and checking to see that we haven't previously set it to a mine. If we have, then we loop back and get another set of X and Y coordinates. Not the most elegant way of doing it, but for this case it's just fine. And here we set the mine and the array X and Y to 1, 1 being there's a mine. Okay, let's set the grid to -1. I'm just using -1 to say that that position in the grid has not been revealed yet. And so that just loops through all the rows and columns to set it all to -1. Now we clear the screen and do a couple of go subs to render the header and the actual grid. For the next section, I'll just jump to what it looks like on the Commodore 64, because the pesky characters much more legible here than they are in PRG Studio. So this section just generates grids, and you can see the characters I'm using all part of the pesky character set. So this is the top of the grid, and then I use a mid string for the various characters. So if the display array value is -2 or -1, you get that checkerboard pattern. 0 is blank, 1 is 1, 2 is 2, 3 is 3, and all these characters in front of these numbers or pesky characters set the different colors. And 7, 8, and 9 is a flag mine, 10 is an actual mine, and 11 is an X, indicating that you actually selected a flag where there wasn't a mine, and that comes out at the end once you've hit a mine. And between all these lines, or this line of pesky characters, the width of these characters is the input columns times 2 -2, and that just uses the left to just render as many of these characters as we need, depending on the inputted number of columns. So, and then we go loop through that, and then down the bottom we place these the bottom of the grid characters. And now back to PRG Studio for the main loop. Here we set the memory location for our current position on the grid, our X coordinate and Y coordinate, with some multiplications to position it correctly, considering the spacing required for the grid itself. We take P, which is having a look in that memory location, and we get G string, which is a key input. Now this kind of bizarre line, what we're doing here is we're getting a timer value, which is an inbuilt function within the Commodore 64, dividing it by 15, and then dividing again by 2, and then comparing it with the integer value of it, and see if it's odd or even. And depending on whether it's odd or even, it will flash the cursor at the location that we're currently on. And by flashing, all we're doing is we're getting the current value in that memory location, adding 128 to it, which puts it in reverse, and then taking 128 away from it again. It goes back to normal, and it'll cycle through that, making it flash based on this timer value. If nothing has been hit, no keys have been hit, then G string is blank, and we go back to 210, and that's all we're doing, just flashing the cursor until we get a key input. Once we do, we have a quick look back at that memory location. If it's greater than 128, we know it's in reverse, and we need to switch it back to normal text. So we poke the location with the current value minus 128. So that's just the flashing of the cursor. Let's go to the first character that we're going to interrogate, which is a space key, which flags our mines. So if it's been hit, we then have a look and see if it's a unrevealed location on the grid, in which case it is. We'll set it to 9, which indicates that it's a flag, and then we change the screen and color memory map locations to reflect the graphical image, or PETSCI character I should say, of that particular the circle, which I use as the flag for the mine. And we also increment the number of mines, the number of flags with DC. If, however, the space key is hit and that particular location has already been flagged, we're going to set it back to it being unrevealed and reset the location. So that allows us to toggle that particular flagging feature. And now this again just checks if the space button has been pressed, then we go and reset the header. The header contains a count of the amount of flags that have been placed on the grid. Now we have a look at character string 13, which is the enter key, and that checks for a mine. We go to 300, go sub 300, which is the routine to have a look and process the selection of the mine. Now we look for characters S and W and D and A, and they just simply move us around the grid. We check that we don't exceed any limits and stay on the grid. And yeah, that's basically it. Once we've gone through that, we're back to 200, which is the beginning of the main loop. Let's check out the part of the code that actually detects if you've hit a mine or not. And this is probably the most interesting part because it contains what I believe is called a flood fill, where you go through searching an ever-increasing part of the grid looking for areas that are blank and don't have any mines. And let's go through that. So first thing we do is check if there's a mine there. And if they've tried to reveal a location on the grid where there's a mine, bang, we go to part of the code where we basically lose the game. If that area of the grid has already been seen as blank, so there's a pointless key press there basically, then we'll just return. If none of those criteria have been met, we'll continue on and reset a counter for the queue. This is a queue of locations that we're going to use to inspect to see if there's any mines. Well, let's start by setting our initial point in the queue. So the QX and QY, the X and Y locations that we enter into the queue, and DX and DY are the current locations. And we've increment the total number of entries in the queue by 1. So we're setting our first queue entry, and 350 is where we actually process that queue. We'll come back to 350, but bombs counted, BC, is what's returned from this go sub, and if there haven't been any bombs detected there, then it'll go to this line here, which we'll cover in a minute. But just before we do, let's now assume that there was a bomb detected there. So this is a scenario where we don't then ever expand out looking for more blank spaces. There's actually a bomb being detected at that location, so we store the count of the bombs in the display array for the grid, and we just put the number directly poked it into the memory location, and so that's 48 plus the number of counted bombs, and we also set the color, and then we return because we're done. But in the instance where there aren't any bombs, we then need to go and start looking around, expanding out this grid, looking for the next bomb. So in this instance, I've clicked here, and as you can see, it expanded all this area out, looking for the edges where there's going to be numbers indicating that there's bombs in that area. So if you're familiar with the game, that should be clear. I haven't done too bad a job of trying to describe it. Okay, so let's go through this process where we do what's called the flood fill, and that starts at 350. So we set the count to 0, so there's no bombs. We then go from the X and Y coordinates, 1 prior to 1 after the X and Y coordinates that's stored in the queue. We check if we're outside the grid. If we are, then we just skip down to the next and work our way through the 4 next loops. If we're actually at the center of the grid, we don't need to interrogate that, so we skip that as well. But if outside these criteria, we've got a counter here for our bombs counted, and we just increment that by by the value in the mine. So if there's a mine there, that'll be 1, and so it'll increment that by 1, and around we go through that loop. So that's an initial run, and now we do a broader search. So we set the mine, if it's 0 in that location, then we actually put the counted value in that displayed location in the grid. So if the search found a mine, then it returns and we're done. So this is an instance where we've clicked on one of these locations where there's a mine in that area, and it'll return the count of the amount of mines surrounding it. So what happens if we've clicked where there are no mines? Like in this example where I've clicked down here, this is where we need to expand that out. So we then need to have a look and see what's in the surrounding area. So we do another search, very much like what we did above. So it's basically the same code as above with a few changes. So if it's on the display grid as -1, that means we've already checked in that location, so we don't need to check it again, so we just skip it. And if we then do find that there's a mine there, we then add it to the queue. So this is the queue again. So as you're going through, as you try and process the queue could actually be increasing quicker than you're processing it. But at some point it's going to start catching up and you're going to get through everything you need to cover in the flood fill. And then we next again, and then we return. And so the key part here is up here where the queue counter gets incremented until we get to the total number of entries in the queue, and it'll keep going through 350, which we've just processed, which we've just described now, which processes all those searches, and we keep going through these two lines until we've gone through the entire queue, with the queue incrementing typically as we work our way through it, and until we've completed the flood fill. I'm not sure how well I explain that. It's quite a confusing concept. There's plenty of literature on the web if you want to go through this in more detail, and there's certainly more than one way of doing this. In fact, there's lots of ways, and flood fill is actually something that has lots of applications and lots of areas of programming, and there are many techniques which do this. So if you want to have a look, just Google flood fill, and I'm sure you'll get plenty of information. If you're still there and you survive the description of flood fill, the rest is really easy, and then we're done. So we've just got the 400, which is where we hit a mine. Why do I have 338? I don't know what's going on there, but that's a bit redundant. We'll get rid of that. So we go through the rows and columns. If there's a mine, then we display a mine. So this is after you've hit the mine, it then shows you where all the mines are, and also if you've put a flag in the location where there wasn't a mine, it'll highlight that with the X, and that's what we do here. And then we go back, reset up the screen, and then we wait for pressing the R to restart, and then we just run the program again. Very simple. And this 500 is where we check to see if you've actually managed to put the flags on all the mines, and we again go through. If there's a mine there, and if the DX doesn't equal 9, which means it's a bad flag, we then return to the program. Otherwise, if it goes through this and passes this criteria, and we get to the end, then you've done. Congratulations, you win. In the description below, you'll find a link to this disk image where I've got 4 versions of the game. I've made a port out to the VIC-20, which is really just adjusting it for the different screen size. For the 3K file, I've also limited how big you can make the grid due to the amount of memory available. And I've also made an 8K plus version where the limitations in terms of the size of the grid of the game is limited by the smaller screen layout with, I think, 22 across. I've just made it to fit the screen as best I can. Now the MSC64 comp is the compiled version, which gives us significant improvement in performance, mainly when we're doing the flood fills. They are much quicker than the just running off the interpreted basic, which is the bottom file there. If you haven't had enough of me droning on so far, I think this will get rid of you. I'm going to have a go at the game, watching someone else play Minesweeper. Yeah. Okay. I like to start in the corners. Hopefully I get a good flood fill. No luck so far. Go. Oh, that's not much. Anyway, let's just pick another point at random. I hate guessing, but I do like to start with a decent fill, because so far there we go. like I was about to say, there wasn't really much to go on before, but that 1 here means there's 1 mine in the area immediately around it, which would be that one. That 2, well, that's not clear at all, but that would be a mine. That would be a mine. That would be a mine. That wouldn't, because of that one there, and that one there is telling me this is not a mine. That 2 is telling me this is a mine. That 2 is telling me this isn't a mine. This is... Ooh, 2. That would mean that's not, and that is, and that's not, and not, and not. Told you this would be boring. Okay. Oh, we got another flood fill, yay. Now, do we have to start guessing 2, which would mean that's not 2, would mean that's not, that would be... That would be... And that wouldn't, nor would those ones. Nor would those 2, that's definitely 1 there, and that wouldn't. That would, that wouldn't, and that wouldn't. Yeah, we got all that done. Hopefully that... No, that would be alright, I guess, wouldn't they? Okay, 3, that's 1, that wouldn't be 1, neither would that. That's 3. Those 2 would have to be, because that's a 3, so I've got 3 in that area, that's a 2. Oh, no, that's better. There we go. Oh, that would have to be 1, wouldn't it, because of that 3 there. That wouldn't be 1, nor would that. That would be, that wouldn't. Oh no! So close. Anyway, like and subscribe and all that. I hope you have more luck with this game than I am. Thanks for watching. Ta.